what. So we'll just get right into it. Let me just make sure I have the window pulled up. Okay. Just making sure everything is running. Okay, that looks pretty good. All right. You are in the webinar. Got it. All right, everyone. Thank you so much for joining. These have already been fantastic questions. Again, I'll be looking at the chat, going through answering questions as they come up. I'm Amber, an ML engineer here at Arise, and I mostly focus on building with the community and developer friendly options. So you might have seen me in a lot of the different events, the Arise courses, Arise workshops, and I'm obviously the host of this showcase for LLMs. So we'll get started. If you've tuned in to Arise and what we've been doing for a while, you might have seen these 5 pillars we've been talking about this year, which are evaluation, traces and spans, prompt engineering, search and retrieval, and fine-tuning, really key categories that make up LLM observability. The main differences I find are that the prompt engineering, search and retrieval, and fine-tuning are more tools to be leveraged when building LLM application systems, whereas evaluations and traces and spans are going to be used to track and evaluate those systems. So we're going to briefly talk about traces and spans just so you can understand the demo I'm going to show. So traces and spans, if you're using an LLM system, any interactions you have with that LLM system will be documented in a callback system by a trace. So if you're using LangChain, LlamaIndex, all of those have callback systems. And this trace, within this trace are all the different span kinds. And that's every execution related to the LLM application step. So you can annotate these however you'd like. You can annotate the embedding step, the retriever step, or give it a general term like chain. The LLM is pretty self-explanatory. Anytime you invoke the large language model, anytime you're using a secondary tool, like one of the many tools that are being used, that can be like an API or a function that's invoked on behalf of the LLM. Similarly with agents, if you're using an agent in the process, any in-between steps essentially are going to be your chains. And then you do have your embeddings. Now, these embeddings don't have to be a vector database. It could be any unstructured data. You have a retriever, and then a lot of times now we are seeing the re-ranker as part of the search and retrieval process. So here's our standard LLM application system where you start with a user query. That query is then turned into an embedding. That embedding is then put in a vector, or is compared to a vector database. You're finding the documents most similar to that query in this vector space. And then with leveraging from a prompt and LLM, you generate a response from those relevant documents and return that to the user. And so each one of these steps, so the single query, like this single process invoked once, is going to be a single trace. And then each step, so each intermediate step is going to be a span. And so this is really how you're going to start troubleshooting these large language models in production, because there's evaluating just the LLM, which for these third-party LLMs, you're not really doing the same kind of evaluations you would when you would build your own ML model a few years ago, right? A lot of the evaluations, the benchmarking tools, those have been done. You're looking more from a system evaluation. So you're evaluating your prompt, you're evaluating the relevance of your documents, you're evaluating the response. Is this correct? Is this hallucinated? And doing all that before you even get to the user feedback option. Just briefly for search and retrieval, Tav's going to go through a talk on RAG systems. But again, you're going to have this knowledge base, you're going to have the user query, you're going to look up the documents that are most similar to that user query. And essentially, you're taking the chunks of this document that have relevant information for that query, and you're generating a response. And then you can evaluate the relevance of those documents before even looking at hallucinations from the LLM. And then for evaluations, I've been talking a lot. I brought my jolly mug for the vibes. In terms of evaluations, this is where things have been getting very interesting, because your evaluations used to be, okay, I'm going to look at my precision, my recall for these models, but now evaluation is coming in a lot of forms. We're still seeing user-provided feedback, but most of the time this is once your LM application system has already been tested and it's been vetted and it's been pushed through. Your task-based metrics, which can come during the experimental process and afterwards. But we're seeing a lot more around this LLM-assisted evaluation, where you're using a secondary LLM to evaluate the process of kind of the prompt selection, the document selection, the explanations that are being used, and we're going to get more into this LLM-assisted evaluation. If you attended any of the advanced evals lectures, Sarah can also drop the advanced evals lectures in the chat, along with we have courses specifically on traces and spans. You can take those free self-paced courses, just so you're aware, like the additional material. But the workshops earlier this month were covering the formats of evaluation. So we talked about a numeric evaluation, these categorical. This actually goes a lot with a question asked in the chat for types of outputs and how to evaluate them. We see a lot of multi-output, so trying to figure out, like, is something correct or incorrect? Is it concise or rather verbose? As well as kind of a multi-class where you can give maybe a 1-star, 2-star, 3-star rating. Okay, I'm going to briefly just check the Q&A here. Got a question from AJ. I'm going to click answer live. Are there examples of how one specific app is instrumented with Arise AI for observability? Great question. We're going to get into specifics. And also, I will mention, like, we have 2 products. I'm going to talk about, like, the differences between there and what you should use if you're experimenting versus if you're like an enterprise software. So depending, like, is this product live? Are you building like a company around this product, and what to kind of keep in mind there? But yes, we do have different examples based on your use case. As Jared said, it really depends on the use case, and we do have a lot of examples for these language-specific tasks. Okay, question from Alex. I already see the CI/CD process. When do you run the evaluation in the lifetime of the LLM app? Great question. You're running it at all times. So this example here, Alex, and I'll just exit the chat. This example here, for like when you run evaluations, you're constantly running evaluations. Every time your user asks a query, that query interacts with a chatbot, you're generating a response, you're evaluating each time, are these documents relevant? Are these documents relevant that I'm using to generate a response? Is the question correct? As in, is it hallucinated or is it factual? And you'll see the differences here, but you're constantly evaluating each part of that pipeline, in addition to factors like token count and latency. And these are the 2 products I wanted to mention. Like, if you're in the experimental phase, you're going to want to use Phoenix, which is our open source offering. This is for your unstructured use cases. And then we do have a free version of Arise, and then scaled up to the level of kind of inferences and models that your team's working with. So Arise for monitoring, and a lot of times this is for use cases that leverage performance metrics for data quality issues, drift. So a lot of times more traditional models, but we do have unstructured models in Arise as well. And we do have a prompt playground. I can mention more of that in the community chat, but this one is going to be focused mostly on Phoenix development and evaluations. And in terms of the LLM development journey, we're working with a lot of teams that already have Arise enabled because they have production monitoring and tracing, they have the evaluation analysis, but I think a lot more teams are still in this experimental phase of, new models are constantly coming out. They want to be able to change out the model. They want to be able to do debugging of these different spans. They want to do RAG benchmarking. And so that's why we do recommend at least using Phoenix as well as Arise, like if you are getting into the process of developing LLM applications. All right, I'll pop into the chat a little bit more. Questions that will be answered once I show you Phoenix in action, I might just leave and come back to. Okay, yes, so all right, that is definitely a question for Phoenix. So I will be answering that when I show the demo. Matthias is asking a question. How do you avoid bias in user feedback? Users tend to report bad behavior more often than good behavior. That's an excellent question, Matthias. And I think that's why having evaluations at each stage, like for recommendations and for responses generated from language models, these are, first, they're non-deterministic models. And secondly, like it's subjective. Whatever the answer comes out, like I might love that answer or that recommendation, and someone else might get the exact same answer based on the exact same question and have different feedback. So I think the key thing here for like avoiding bias in user feedback is having a collection of evaluations instead of just basing if you're going to change up the model on one type of evaluation metric. So as long as things are working in production and your latency is low, your evals are doing great, there obviously might be some bias involved. We do have bias metrics in the Arise platform, just like parity metrics, and we do have an entire unit in one of the courses on how to combat bias explicitly, so like group versus individual bias. Okay, great. I'll dive more into that in a bit. But for why you might want to leverage callback systems and use a product like Phoenix, if you've kind of invoked these LLMs, you'll notice it only takes a few lines of code to actually run these large language models. But what you're getting is you're getting a lot of calls that are actually happening under the hood that you might not be aware of. If anyone's been surprised on their OpenAI bill at the end of the month, you know what I mean. There's a lot happening that's hard to keep track of. And so you want to be able to have that observability component to understand what's happening. And what this can look like is if you make a call to an LLM, you have a chain, you have all your span types, you can add an evaluation at this classification stage. You can add an evaluation for how good your structured data extraction is. You can add an evaluation for if this retrieval is relevant or irrelevant. And so chatbot user frustration, like they gave a thumbs up for this structured data extraction. That was a good, it met all the criteria. The classification is correct, but you're being told that the documents you have aren't the most relevant. And a lot of times this can be based on several factors, but depending on your criteria, maybe even depending on evaluations you might be using, this is going to say irrelevant. So for how evaluations work, how they're working under the hood, especially with Phoenix, you have a given span type. So any step that you can add an evaluation to, and then you're given the retrieval span, which has your input. So this is the user query. These are the documents. This is what it output. And then you can have evaluation templates, and you can have built-in evals. So different evals libraries that you can use within Phoenix. And then Phoenix does have its own evaluation library, as well as like evaluation templates. So this is where you would leverage you can leverage a secondary large language model. You can use a prompt template to say, okay, you're comparing these. This is what I want you to do. Tell me that it is relevant if it meets this criteria and irrelevant if it meets this criteria. So in the same way, humans label data, like you have a criteria to follow, and then you're doing those criteria checks. So very similar process. In addition to so first I just want to mention Phoenix, any unstructured data, like we do UMAP projections, we do clustering, but Phoenix has really been leveraged recently for support of search and retrieval use cases, especially evaluations, custom templates, and for leveraging different models. I think a lot of the examples we show are with OpenAI models, but we do it for a variety of different models. If you have a particular model, just ask me, because we have a lot of different examples and notebooks that you can use depending on which model you want to use, or if you have your own open source LLM that you've been working with. Okay, let's head to the demo portion. Okay, I think I just ran this. So Sarah has already shared this in the chat. Thank you, Sarah. This is a notebook. So you don't actually need the OpenAI API keys to run this. If you run the first 2 cells, it will open your LLM evaluation with Phoenix. But if you want to run it all from scratch and see all the intermediate steps for how you build the search and retrieval system, how you added each individual evaluation metric, you can do that as well. All right, let me look at some of the questions just to clarify everything before I get into Phoenix and the full suite of evaluations. Okay. So I've just been speaking a lot. All right, AJ is asking a question. Can the observability layer negatively affect the performance of the app being observed? Also, do you have benchmarks of overrides limits when it comes to handling all your clients? Great questions, AJ. Okay, so for the first one, can the observability layer negatively affect the performance? No, I don't think so. Not that I've ever seen. The observability layer just shows you what's going on, and it's not, it's not like quantum physics where you observe it and something else will happen, right? So everything that's being observed only helps you understand what's going on more. So if something's gone wrong, this is just going to help you pinpoint where something went wrong at. And we provide benchmarks in our documentation. In terms of our client, we can help the clients benchmark. We don't share that information, but yeah, like we do help with the benchmarking for them. All right. Alex said, ignore if it's already been answered. Can you set your own rules for metrics? Absolutely. Every single metric on here is either custom or just a metric that we chose because it looks best. Do you support, so we support all like the GPT models. We support Llama, Vertex. Yeah. So we support, I believe, all of those that have been asked. And no, yeah, it also works for open source models. All right, so that kind of caught me up on some of the Q&A. Let's dive into Phoenix. If I have to pause to take a drink of tea, I apologize. I think I'm just starting to lose my voice a little bit. So let's dive into Phoenix here. So from our Phoenix view, we can see the total traces. So essentially, we're querying our Arise database. We're asking it inputs and getting our outputs, and then we're adding overall evaluations. So at first glance, using a a trace system like Phoenix, you're able to see, all right, here's the latency of my calls. This one query had a little bit higher latency. You're able to see the token count, and you can filter on individual evaluations and spans. So if I click onto a question like, how do I delete a model from the Arise platform? I could continue to click into the individual span types. I can also go into spans and then look at every single individual span. So my LLM span, my embedding span, my retriever span, and go through those in particular. And then these are where the evaluations take place. So our relevance values, our precisions. So these are all relevance values that we decided to calculate to make sure that we are retrieving the most relevant information. And then we have hallucinations, asking if something's correct, and that's based on the overall trace. So trace evaluations, span evaluations, and kind of any evaluations you can think of, you can attach to these questions. Okay. Now, if you notice here for our evaluations, we're seeing a factual and correct, and like, that's good. So we're essentially asking, like, is this hallucinated? No, it's not hallucinated. It's factual. Okay, is this correct? Yes, it's correct. And that's great until we get to this third query, which we're seeing, like, is this hallucinated? And it is hallucinated. So we don't like that it's hallucinated. We don't know, like, that this output has been hallucinated. And based on the correctness, we're actually now seeing that it's incorrect. So let's dive a little bit deeper into these examples. So if I click on that chain, it's going to pop up into its own window. So I'm able to click on, so like, what are my queries? What are my attributes? What are my evaluations? And you can look into all that. So this is the input. How do I log a prediction using so this is the Arise Python SDK. You are given a set output, and then I have my evaluation metrics, where I am saying a score of 1 is factual, meaning that the model did not hallucinate. And then using like the open, I believe this is the open AI function calling API for explanations. So it's going to provide an explanation as well as a score based on a prompt. So here we're seeing from the explanation, the answer provided is in line with the information given to the reference text. So we're saying, okay, this is factual. And then, is this correct? We're saying a score of 0 means that it is correct, and 1 meaning it's incorrect. And so the answer explains how to log a prediction using the Python SDK. So 1 is based on the documents, like, are the documents correct? And then 1's based on the output. Is the output hallucinated or is it factual? And you can look at the individual documents. So we can look at the info from the embeddings, attributes of embeddings. But what's really interesting is looking at the retrieved document. So you can go in and look at the actual retrieved documents that you have, their evaluation scores. So if you use something like an NDCG or a mean average precision or a different kind of ranking or relevance metric, you can add that as a relevance score. And you can have as many evaluations on it as you want, but it's just really nice being able to see the actual documents that have been returned, so you understand why something may or may not be relevant or may not have given you the correct answer. And then you're given the full set of attributes. If I do the same for the large language model, I can look into the info available. So here's my input message. And I can look at my prompt template. So this is the prompt template that I'm using for my large language model. Various parameters, so the actual model I'm using, temperature, and this does work for other LLMs as well. But being able to also see your prompt template, in the Arise platform, we have a prompt playground, or you can leverage a tool like Prompt Layer that Jared demoed, to be able to see the differences and to experiment with those prompt templates. We see that adding a search and retrieval method, adding a prompt template are the most effective ways to improve that outcome. We're seeing more and more fine-tuning come up as fine-tuning becomes an easier process to deal with, but these are still the main options. If I go to when we have a hallucinated incorrect answer, and I go into that particular trace, so how do I delete a model? This sounds like it could be promising. Like to delete a model, you might want to go and check with the administration section, but it doesn't really give you exactly how. I think what happened here in the docs is that it looked up a different question, like how to delete something else, and gave that response. And if I go in and look at that for evaluations, I bet that's what I'm going to find. So here we see it, we're saying it's hallucinated. The reference text provides information about navigating, blah, blah, blah. It does not provide any information on how to delete a model. And again, these are the explanations leveraged from OpenAI. Okay, and like we're looking at the model here. All right, now I'm gonna go into chat because just a quick time check. I think we have, so my session stops in, I think 4 minutes, but I have a 5-minute buffer too, so I could probably continue to answer questions. All right. Okay, I see some great kind of back and forth. Okay. It's a little complicated in the chat, so I'm going to stick with the Q&A here. Okay, those ones are done. All right, Alex asking, can you please explain again how the hallucination and the correctness are calculated? What's the ground truth in this context? Great question, Alex. So for this use case, I'm not sure if this data set actually has a ground truth. That's why we're using explanations. So like explain whether or not you think the answer is in here. So in a similar way that you first start to label data sets, with a human in the loop, like you're asking them to provide a label and an explanation for why you think the data should be labeled this way. Answer live. So there's not necessarily a ground truth needed. And that's what is becoming so interesting with these LLM use cases. It's not that you necessarily need that golden data set to start with, or my latest article on Towards Data Science talks about how we can leverage explanation to also update those golden data sets. Hallucination is, we actually have a hallucination notebook, but hallucination is calculated essentially with a given prompt. So having an LLM say it is hallucinated if it doesn't directly answer these questions. Let me see if I can pull up the prompt here. So if I go in the LLM and I look at the prompt template, okay, so this is the Q&A prompt. So essentially you're going to have, and there's different hallucination metrics. If you look at the LLM leaderboards and the kind of benchmark methods, there are different hallucination metrics or different hallucination prompts that you can leverage to essentially classify something as hallucinated or factual. LLMs aren't good with regression classification, or they aren't good with using regression, but using classification, they have shown to be pretty adept at. So you can leverage those LLMs as that LLM assisted evaluation I talked about earlier to classify something as hallucinated or factual. Similarly, you can classify the documents that were returned, so the documents that were retrieved from your evaluation. You can classify these as relevant, irrelevant with LLM assisted evaluation. So that's the key thing here. If you have given performance metrics like precision and recall, there's a good chance that you have a ground truth data set that you're working with. The problem is with all these use cases now being not all these use cases using models that are non-deterministic. When you have a stochastic model, like you can run that 5 times, and maybe 4 times you get it to say that it's relevant, and 1 time you get it to say that it's irrelevant. But by adding the explanations with it, the explanations are computationally expensive. They do take more time, but it's very interesting seeing how when you're asked to provide an evaluation along with the label, sometimes that can go against any ground truth, and it could go against the evaluation from a different large language model. Maybe that's getting a little too into the weeds there. Okay. I think I've answered a lot of these. Let me just clear out the Q&A. We do have 5 minutes till the next session here. And I will announce the, so we actually have 2 winners. Sarah just sent me the 2 winners for the O'Reilly book, and Sarah's going to reach out to you. We have Matthias and Alex. So congrats, folks. Sarah's going to reach out and make sure to get your information so that she can send you the book. All right. I'll use the last few minutes to continue answering these questions. All right. AJ's asking, can the observability layer... Oh, sorry. I did answer that one. Okay. I need to start clicking done when I've answered these, because you guys ask so many amazing questions. I need to be able to keep track of them. I was like, maybe I should just have like a spans and traces workflow for all the questions coming in. All right, AJ's asking, the outputs from Arise's observations, where are they stored? That's a great question. So you can store them however you like. So everything that you're seeing here in the Arise, in the Phoenix notebook, you can put back into your own IDE, into your own workflow, however you run your system. If you're using like a cloud provider, you can store information there. So however you want, it's pretty easy because we're mostly just leveraging inputs and outputs, so they can pretty easily be stored anywhere, and they can be pulled from anywhere as well. Do you get fuzzy results from the evaluator LLM? It depends. And that's what's nice, and what Jared was pretty much talking about, like continue to experiment on these prompts, because when you used to build regression models, it was very clear. And when you had, and when you have classification, you expect it to be a little bit more clear, but sometimes it isn't, especially when you rerun a model and it gives you a different classification. So making sure that your prompt is as focused as possible is going to be key to really diving in deeper there for more information. Okay. I think we have time for 1 or 2 more questions. We have a question from Arca Provo. Will it also work for coding related tasks? For example, if I have a RAG system that instead of dealing with regular text, works with code repositories paired with Code Llama, will this evaluation be effective for it as well? So code related tasks. Depending on if you have, if you're looking for that evaluation feedback. So if you're invoking an LLM and you have an LLM application system and you want to look at those individual processes, then yes, it kind of depends like the value that you would get out of it. So if you're looking for just results, and you don't care as much about like the individual steps that led to that result, maybe not. But if you care about the observability and trying to optimize performance for your large language model, then I highly recommend testing it out. We also do have Phoenix leveraged for debugging, especially more of our unstructured capabilities. And I'm happy to talk to you more about our unstructured capabilities and our clustering and our performance metrics. This is just for our tracing workflow. We also have workflows for inferences if you do have an application that already has users and you're getting those inferences back. A question about security, privacy, and yeah, hack attacks that might target Arise. I will say, so the Arise platform, SOC 2 compliant, HIPAA compliant, enterprise customers, a lot of data. If you have any questions on that or keeping your data secure, I recommend talking with Rise. We have both SaaS and on-prem deployments for our customers depending on their necessities. Again, Phoenix is going to be open source, so you can leverage these experiments, but it's going to be a different level of protection for your data.